Hi, welcome back to my channel. Well, in this video we'll try to learn some of the basic concepts which are involved in testing of hypothesis. What is null hypothesis, what is alternative hypothesis, what are the different steps which are involved in testing of hypothesis. Let us proceed. A statistical hypothesis is an assumption that we make about a population parameter which may or may not be true concerning one or more variables or whatever the variables that are involved in a particular study. According to Professor Morris Hamburg, a hypothesis in statistics is simply a quantitative statement about a population. Or we can say a statistical hypothesis is a statement about a population or a probability distribution which we want to verify on the basis of evidence or on the basis of information which is given by a sample. For example, a coin may be tossed 200 times and we may get 80 times head and tails 120 times. Now the question is that we may be interested in testing a statement or a hypothesis that the coin is unbiased. Now there's an important fact that estimates which are based on sample, they are not equal to the true value or the original value of the population because of the fact there is an existence of inherent variation in the population. So it has to be verified whether the difference between the estimates which are based on sample and the population or the true value is due to the sampling fluctuations or due to the real differences. If the difference is due to the sampling fluctuation, then we can say the sample belongs to the population, and if the difference is real, we have every reason to believe that the sample does not belong to population under study or under question. Now, what are the different steps which are involved in testing of hypothesis? Whenever we are conducting an experiment, either in fields or in labs or we are doing survey, every scientific study starts with a hypothesis. So we have to define the problem. The problem we have to define. Means that we have to set a hypothesis. Now there are two types of hypothesis involved. One is null and another one is alternative hypothesis. Then the next step is to choose the appropriate level of significance at 5% or 1%. That means to choose the margin of error or the maximal error which we are prepared to risk. Then they compute the test of significance like T, Z, F or chi-square. It depends upon the circumstances or the objectives that are involved. Then compare the value which is calculated value of a particular test of significance with its critical value. And the rule is if its calculated value is less than its tabulated value, we can accept a statement or a hypothesis in its own form. Otherwise, we have to reject it. Then as per this acceptance and rejection, we give a conclusion or interpretation. So null and alternative, they are very important. Test statistics, it has to be constructed. Now it depends upon what are you comparing. Are you comparing samples or objects or things in terms of means or in terms of variances? What is the sample size? Now the margin of error, this is very important. Now the table or the critical values, we can say we have to find out from the tables of the tests of significance at a particular level of significance. Now this thing nowadays is not to be done manually due to the involvement of p-value in statistical softwares. Then the null hypothesis will be rejected, or we can say a particular statement will be rejected at a given level of margin of an error or level of significance if the values of the test statistics is greater than or equal to the critical value. Otherwise, it has to be when something is rejected, that means the variation is significant, and if it's accepted in its own form, that means the variation is not significant. Now once you define a problem, you have to set a hypothesis. Now there are two types of hypotheses which are involved in this testing of hypothesis. One is null, which is denoted by this H0, and its rival hypothesis which is known as H1. So the null hypothesis is a hypothesis which is under verification and it is denoted by this H0, or we can say a hypothesis which is tested for its possible rejection, or it's a hypothesis of no difference. The rival hypothesis, or the hypothesis which is likely to be accepted in the event of rejection of this null hypothesis, is called alternative hypothesis. So once we set the null hypothesis, now it depends upon the situation or the test of significance whether we are going to accept it or reject it. So during this course of acceptance and rejection, we used to commit two types of errors, and they are known as type 1 error and type 2 error. So whenever we reject a hypothesis which is in true state, we are committing type 1 error, and we are whenever we are accepting a hypothesis which is not in a true state, but still we are accepting it, that means we are committing type 2 error. Take an example of a doctor and a patient. There's a situation that there's a genuine doctor and he is prescribing some medicines to a patient which are genuine, which is verified, and this doctor is well qualified, or we can say in our term he is MCI qualified, a well professional, and he is giving some medicines to this patient. But this patient, instead of consuming this medicine, he is not taking them, he is using the home remedies. In this case, the claim that is given, or the medicines or the prescription that is given by the doctor is true, but the patient is not accepting it, he is rejecting his claim. That means this is a clear example of type 1 error. Take another example. There is a doctor and patient again, but in this scenario or in this situation, the doctor is not genuine. He is prescribing some medicines which has got some side effect. But in this situation, the patient is consuming these medicines. So the claim or the prescription that is given by the doctor is not true, but still the patient is accepting it. So in this case, he is committing type 2 error. So when we reject a hypothesis which is in true state, we are committing type 1 error, and when we accept a hypothesis which is not in a true state, we are committing type 2 error. Otherwise, the other two things which are in blue, they are right decisions. So these two in red, they are wrong decisions. Now, level of significance, or we can say the margin of error, or the maximum allowable error which we are prepared to risk. So the probability of committing type 1 error is nothing. It is denoted by alpha, and it is known as level of significance. This can be measured in terms of percentage, 5% or 1%. 5% means we are 95% confident that the decision to reject a null hypothesis is true. Or 1% means we are 99% confident that the decision we have taken to reject a particular hypothesis is true. Or if we are conducting an experiment 100 times, 95 times we are expecting the same things, only there will be a variation of 5 out of 100. In case of agricultural sciences, we can take an error of margin of an error of 5%. But in case of medical sciences, a lot of risk is involved because we are dealing with the patients, we are dealing with the human lives in medical sciences. So 5%, even 1% is not taken as a level of significance. A very low value of level of significance is taken. And the probability of committing type 2 error is nothing, it is denoted by beta, and 1 minus beta is nothing, it is known as power of test. Now this concept is very much used when we will be discussing or evaluating the distinguishing features between parametric and non-parametric tests. Now there is an important thing or a concept, critical region, in case of testing of hypothesis. So in a test or a test of statistics, the area under the probability density curve is usually divided into two things. One is acceptance region, which is visible by means of this yellow color, and there is another region that is known as area of rejection. The region of rejection is the region in which this null hypothesis is rejected. It indicates if the value of test statistics lies in this region, the null hypothesis will be rejected, and this region is called critical region. The area of critical region is equal to the margin of error or the level of significance. Now, once we accept or reject it, now how we are going to compute a particular value? How we are going to compare the things? What are the different statistical procedures or the statistical tests by means of which we can say a particular hypothesis has to be accepted, a particular hypothesis has to be rejected? For that, we need these tests of significance or test of statistics. The test statistics defines the difference between the sample statistics value and hypothetical value divided by the standard error, or we can say a traditional test of significance is nothing. It's the deviation of sample mean from its population mean in terms of standard error. So we have two types of test. One is known as one-tailed test, another one is known as two-tailed test. A very simple to understand these one-tail and two-tail. A test with a null hypothesis in this form against an alternative hypothesis, it is called two-tailed. In this, the in this case the critical region is located on both tails of the distribution. So we might be having both, or we can say it's the right tail or left tail. So in this case the critical region is located on both, say on both tails of the distribution. If you have a distribution, if the critical region is located on both, we can say it is a clear case of two-tail test. A test with the null hypothesis like this, we can say it's a right tail or a left tail, is called one-tail test. In this, the critical region is located on one tail of the distribution. If it is on both sides, we can say it's a two-tail test, like in this figure here. And if it is only on the one side, we can say it's the right tail if it's on the right side, and if it's on the left side. For example, suppose a farmer is testing two different fertilizers, say fertilizer A and fertilizer B, to determine their impact on crop yield. So what is the example of one tail and what is the example of two tail in this scenario? The null hypothesis in case of one tail is fertilizer A is equally or less effective than the fertilizer B in increasing the crop yield, and alternative hypothesis under one tail test will be fertilizer A is significantly more effective than fertilizer B. Now in case of two tail, the null hypothesis is the effectiveness of the fertilizer A and fertilizer B in increasing the crop yield is same. Same is the case with here. Now the effectiveness of the fertilizer and fertilizer B in increasing the yield is significantly different. So this is the clear example by means we can differentiate a one tail with two tail test. Now as far as these tests of significance are concerned, we have different types of tests and they have been categorized based on the sample size and based on the population standard deviation. We have t-test, we have z-test. There are different forms of t-test, one sample, two sample, with equal, unequal, peer t-test, variance ratio test, f-test, and which are used or because things have to be compared on the basis of means or on the basis of variances. So in the next video we'll be discussing all these tests of significance in detail. Thank you very much.